All right, you guys, today we have quiz 2 review for chapter 9. So we're doing quiz 2 review. This is chapter 9, and on your note card you should already have these 4 formulas. Okay, here's 2 and here's 2. And notice I have the black ones are for interior angles, meaning inside of the polygon, and the blue ones are for exterior angles, meaning outside the polygon. And those are the formulas. Make sure you check them, double check them, make sure you have it written down correctly, and make sure that you're paying close attention to the difference between when I'm asking for the sum, which means all of them, or one of the angles. Okay, same thing for exterior. Do I want all of the exterior angles or do I want one of them? So that is how we're going to be choosing which formula to be using. So number 1 says the sum of the interior angles. So I'm going to look through my formulas very carefully. Sum interior, I'm using this formula right there, okay? And it's that simple. I'm going to write the sum interior formula is n minus 2 times 180. Okay, and the n, okay, what do I have to do here? Oh, I already numbered all of these, or you can just count them, but there are 10 of the sides, and that means that n equals 10. So I'm going to do 10 minus 2 times 180, which is 8 times 180. And how do I type that thing into the calculator? Well, I got to open my calculator, it looks like. Here it is. And I'm going to slide that over. Open Notability. Apologies for that. I've got 8 times 180, which is 1440. Let's try number 2. I'll leave my calculator open. The sum of the exterior angles. Look at that. That is one of my blue formulas. Sum exterior. Hey, look, it's not even a formula. It is 360. And there's nowhere to even plug in the number of sides, which for a pentagon is 5, because look, every single time all the exterior angles always add up to 360. So that's our answer, and we move on. Number 3, calculate the measure of angle 1. Well, angle 1 is one interior angle. You can see angle 1 is just one angle, and it is on the inside of the octagon, okay? So I need to look up here, and I am looking for one interior angle. Here is my formula. That one interior. Don't choose the one that says exterior if I'm asking you about an angle that is inside the octagon. So I'm going to write that formula. It is n minus 2 times 180 divided by n. And for an octagon, n equals 8. The number of sides, you can count them over here, but I think you remember that an octopus has 8 legs, and so we're going to plug in 8. And I'm going to do 8 minus 2 times 180 divided by 8. So I'll do that in my calculator. 8 minus 2, that's 6, cool, times 180, brilliant, divide by 8, enter, and I get 135. Okay, great. The measure of angle 1, okay, this one is one exterior angle. Look, the 1 is on the outside of the shape. See how it's not on the inside of the shape? It is on the outside, so therefore I am looking for one exterior angle. Let's go up and let's find that really carefully. One exterior is this one. One exterior. I'm doing 360 divided by n. So that means I'm taking 360 divided by n. And how many sides are there? 1, 2, 3, 4, 5, 6. So 360 divided by 6. Each one is 60 degrees. Okay. Number 5. This one is how it gets maybe a little bit more challenging. How do we figure out one of the missing angles if I know all of the other ones? So you know you have to start with a number and you have to subtract all of them, right? So we need to know what all of the angles add up to when there are 6 sides. You can see that I have them numbered. There are 6 sides here, so it's a hexagon. What is the number that they're supposed to add up to? Well, they're all interior angles. So I'm looking at these black equations up here. They're interior angles for this problem, and I want to know what they add up to, all of them, so that I have a big giant number that I can subtract all the rest. Okay, so I'm going to do the sum interior formula. So I'm going to do n minus 2 times 180, and that's going to give me 6 minus 2, because it's a hexagon, times 180. 6 minus 2 times 180. That's going to tell me that they all add up to 720. That is what all 6 of the angles in here add up to. But I know 5 of them, and I am going to subtract all of those to figure out what's left with A. So I'm going to take the 146 and the 135 and the 90 and the 160 and the 124, and I'm going to be left over with angle A. Okay, the important thing is, you guys, you have to be able to figure out what they all add up to. Okay, so what do they all add up to? That is where we use this formula, which is sum. That's what add means in math. And for 6 sides, they all add up to 720. Subtract all the rest. Here we go. I'm going to subtract all of these. 146, 135. Make sure you type them correctly, you guys. 160, 124, and I'm left over with 65. Okay? Put maybe a star next to that one or something. Make sure you know how to do a problem like that on the quiz. Number 6, calculate the measure of angle 1. As you can tell, hopefully these angles are all exterior angles. They're all on the outside of this shape that has 5 sides. Okay, cool. And so if they all add up to, let's see, they're all exterior. I'm going to do the same thing I did here. The only difference is these are interior, these are exterior. So that's the difference in my formula choosing, okay? Let's see, exterior angles. I need to find what they all add up to. Oh yeah, I forgot. Exterior angles always add up to 360. So that's going to be my starting number, which was different from this starting number because we had to figure out what they all add up to on the inside for a hexagon. On the outside, it doesn't matter how many sides they have. They all add up to 360 every single time. And again, I'm going to subtract the 80 and the 65 and the 50 and the 120. And I'm going to do that real quick. Oops, 360 minus 80 minus 65 minus 50 minus 120. And I'm left over with 45. Can we please zoom out real quick and notice the difference between these two problems? These are interior, these are exterior. That's a different formula. Interior angles, when there are 6 sides, you have to use the formula and figure out that they add up to 720. That's what I started with. And then I subtracted everything. I did the same exact thing for number 6, except I didn't use the interior angle formula. I did the exterior angle formula, which isn't even a formula. It's just a number, which tells me that all the angles, if they're exterior, add up to 360. And then I subtracted and I got this. Number 7, I think, is going to be the same way. These are all exterior angles again. So just like number 6, all the exterior angles always add up to 360. So what I'm going to do is I'm going to subtract 107, and I'm going to subtract 128, and I'm going to subtract 2x, and I'm going to subtract 3x. Okay, this is kind of weird. I'm going to stop here, and I'm going to forget about the 2x and the 3x for a second. I'm just going to do 3x minus 107 minus 128. And that gives me 125. And this combines to negative 5x. So I'm going to put negative 5x because you can't combine you guys' numbers with x's. So I'm going to leave 125 minus 5x, and I'm going to set it equal to 0 because if I subtract everything, that means that there's nothing left, okay? Therefore, I'm just going to take 125 and equal it to 5x, and I'm going to divide both sides by 5. Basically, what I did to get that 5x is I added 5x to both sides so that I could solve for it. Okay, and 125 divided by 5 is 25. That was kind of a hard one, but again, it's very similar to number 6. For number 6, I just subtracted all the angles. For number 7, I tried doing that, but I had a bunch of x's here that I can't combine with whole numbers. So I subtracted these together and got this number. When I take 2x and 3x, that makes 5x. They're both negative. And if I subtract everything, then I'm going to be left over with 0. Okay, so that's why I equaled it to 0, and then I just had to solve it algebraically, and I got 25. All right, the sum of the exterior angles of a heptagon. Sum exterior is 360 always. It's not even a formula. There we go. Find it at the top of your page. Sum exterior is 360. Sum interior. Okay, I have a formula for that. Look it up. It's on the front of the page. Look very carefully. It's n minus 2 times 180. And this polygon, I need to number or count the sides. So when you count them all up, I have them labeled. There are 12 sides, so I'm plugging in 12. Which gives you 10 times 180, which is 1800. That's what they all add up to. All right, on this back page, we have our two area formulas that we learned. So I have this one here, 1/2, or AP divided by 2. Remember that A is the apothem, that's this number. So it's labeled a 3. That is what we're going to put in for A. So I'm going to do that real quick. I'm going to put 3. And do you remember what P means? P means the distance all the way around. And so you don't have to label all of these 4s, but every single side here is 4. If it helps you, you're adding them all up. And the perimeter equals 4 times 8. It's the same thing as doing 4. Don't forget this one. Plus 4 plus 4 plus 4 all the way around is the same thing as doing 4 times 8. So I'm taking 32, and that is my perimeter. And dividing it by 2, because there's a 2 in the formula, okay? So 3 times 32, 3 times 32 divided by 2, and I got 48. Oops. And the very last problem, you guys, this is a regular hexagon, the area of a regular hexagon. So be careful, this is area right here. I guess we have these labeled just like we will on our note card, but the area of a regular hexagon is that really weird looking formula where all you have to do is you plug in the side length. And so make sure that you're not using the 4, that's the apothem. Make sure you use the side length, which is 5. So when I take the 5, I'm going to plug it in right here to S, and I'm going to write it 6 times 5, doesn't look like a 5, squared, radical 3 over 4. How do I type that thing into the calculator? 6 times 5 squared times radical 3. Make sure you know where the radical button is on the calculator, and divide by 4. Enter. 64.95, which rounds to 65.